There's a second way to solve this problem. It's really the same way, but even more formal than what I just described, and it's the method called U substitution, which is introduced in section 5.5. So the book doesn't anticipate using this rule or method here, but it is certainly appropriate to do, and in my estimation, it really is what you should do. The book has put these problems here for you to kind of think the way I just described about it here before it's formalized into what's called U substitution in 5.5. But let's go ahead and apply that technique here, because it's really the most appropriate way to solve this particular problem. So you have sine x cos x here, and we'll make a substitution. We'll let u equal sine x. You'll kind of see how it's similar to what I just did, only just in a more formal way. Du dx would be the cos function. So therefore, du equals cos x dx. I'm going to actually multiply this differential in the denominator over to the other side. We never really moved them around like that before, but you certainly can. Right. So du equals cos x dx. So now what I'm going to do is I'm going to replace all of the expressions in x here with expressions in u. So therefore, this one, sine x, is the original substitution itself, u, and this whole expression here, cos x dx, is du. So therefore, this is the same as the integral of u du, which of course is 1/2 u squared, kind of like we were talking about before, right? Here it is, there's my 1/2 x squared. I was kind of intimating over here, if g prime were x, then you can derive that the outer function that you must have originally had was really a 1/2 x squared. That's kind of what this is doing here. It's showing us the original outer function, because this is really just undoing chain rule, like we did above, just in a more methodological way. Right? So undoing chain rules, so we had 1/2 u squared. There's our outer function. But we made this substitution, so we need to put this back in. We need to put our inner function back in. So we get 1/2 sine squared plus c. We get the exact same thing, of course. Okay, so there's the U substitution approach, and I think it's good to think about problems the way we did up here. Even when you know U substitution, this is still a good way to think. It can actually make it faster to do certain types of problems this way than to do them with the U substitution way. But since we're going to go to 5.5 anyway, it's also good to see this method here.